Hi everyone, in this video we're just going to take the parabola on to the next step, I suppose a little step up in difficulty. We're going to draw something just similar to the last time. We're going to go horizontal. We're going to make it just a different type, so like a satellite dish facing up in the air. I'm going to start off with a box 91 millimeters long. And just go vertical from my 2 points, and I'm going to make it about 43 millimeters tall. And there we are. Now this time I'm just drawing in half. The other half of the parabola would be on over this side, and you can add that after in your own time. So the other half would be over here, again 91 mil over. I'm going to label it this time A, B and C, but this point is the vertex in this curve. So we're looking for a parabola from A that goes down and hits the vertex, and it can be mirrored across then onto the other side after. What we'll find this time is that using just what I had previously said, the first one, 4, 5 or 6 divisions, the maths isn't really going to work out for us. So I'm not going to get into getting a calculator out and dividing this up 5 times into 91. It's not going to be very accurate. So what we'll do instead, we're going to bring back a little construction that would have been learned at a very early stage in technical graphics and graphics, and we're going to divide up this side into 5 equal parts, starting from B or V, it doesn't really matter. I'm going to start from point B. I'm going to draw a random line, random angle. I'm going to get my compass, and I'm going to set any size at all in that compass, and I'll just kind of keep an eye. I want 5 strikes of this size to be able to fit on the line without going off the page. So 1, 2, 3, 4 and 5. So random line at a random angle and 5 random distances, but all equal, stepped out along. I'm going to get my sliding set squares, and I'm going to join the final point to the end of the line that I want to divide. So it's equal divisions of a line here. I'm going to take my sliding set squares and I'm going to work up along for all my other points. Now, of course, going back to the original, so mark the vertex, mark the 2 opposite sides. So the 2 opposite sides of the vertex, if I'm working in this rectangle, would be this one up here and this one over here. So I probably should have maybe done my divisions up at the top, or it's no problem, we can just say, right, we're dividing the 2 opposite sides. I'll take the division and I'll mark it. I'll take my division here and I'll mark it, and do this for all 4. So there's my 5 equal divisions along the opposite side, and I need 5 equal divisions along this side. So again, random line, there's a random angle, and 5 strikes of my compass along that line at any size that you like. 3, 4 and 5. Bring in my sliding set squares again and join the final point to the end of the line I'm dividing, and slide up along to all remaining points. So there's my 2 lines, my 2 sides and 2 rectangles divided up, which was step 3. Step 4 is number away from the vertex. So starting at the vertex now, just because my construction is down here, I won't make the mistake. I'm going to go up and start to number 1. So starting at the vertex, go up to the marked side and go across to number 1, 2, 3 and 4. Starting at the vertex and up. 1, 2, 3 and 4. Now, that is step 4. Step 5 is join the vertex to point 1 and take the other point 1 parallel to the axis. So, what kind of curve? As I said at the start, it's a curve that starts at A and goes down to V. It's not the one that goes up from V, it's the one that comes across. So I'm going to point it towards point 1, which will direct my curve. So from the vertex to point 1 and parallel to the axis. We'll repeat that step for the remaining 3 points. And parallel to the axis from the remaining 3 points at the top. So point 2 hits line 2. Point 3 hits line 3. And point 4 onto line 4. And we freehand in the curve, starting at A, hitting all of our points along, and finishing up at the vertex. I'm not going to go through this, but mirroring across this time, same as every other time. Take a point through the axis at 90 degrees to the axis, mirror it across with your compass, but don't forget as well, through the axis, mirror point A across with your compass, and that will give you the remaining half of the curve. The final parabola I'm going to go through is just at an angle, so I'm going to start off up here, and this time I'm not going to use any particular measurements at all. I'm going to go with a completely random line to start at 60 degrees. I'm going to go off with my 30 degree, and I'm going to take I'm just going to go with the end of this right here, so completely random size rectangle to start this drawing. Now, the type of parabola we're going to, I'll just label everything first. I'm going to have a parabola that goes from point A. I want this to hit a vertex here somewhere in the center of BC, so it goes up and it comes back down and finishes here at point D. So this is our final type of parabola we're going to draw for now. What I want first is I want the center of the side. Now, I just completely guessed this base line. I don't know what size it is, so I'm not going to try and measure and see if I'm even here. I'm just going to take my compass and bisect the line. Now, because this is orientated at 60 degrees, I don't need to bisect above and below the line, because I know that the main axis going through is parallel to the 2 main sides. So if I just bisect in one position only, I can bring it down and I can draw my axis. Once I have my axis, I have a vertex. So that's step 1 done, mark the vertex. This time around we could, I suppose we'll just work with the one here on the left. I have quite a bit of space here. I'm going to disregard the right hand side and just work on the left hand side only. So step 2 was mark the 2 opposite sides. So I have an adjacent side to the left and go to the right, and I have my opposite side here, and I have my opposite side here. Step 3 is to divide up both sides. Now, unless I was very lucky, I'm sure that the maths won't work out and that we won't be able to divide evenly 4, 5 or 6 times. So I'm not even going to check the measurements. I'm just going to start up and I'm going to say, right, I want to divide this side into, I'm going to go with 5 equal spaces. So it's a completely random line. Bring in your compass and whatever you feel will work. Don't set it too small. If you set too small, all your parallel lines are going to be really close and you might lose some accuracy. So don't set too small when you're doing this. I think mine is set to, in this case, maybe around 20 millers, something like that. But there's my 5 equal spaces. And just like before, we'll join the 5th space to the end of the line that we're dividing. And we'll bring in our sliding set squares. There we have one side divided equally. So 1, 2, 3, 4, 5 equal spaces on one side, and I want 5 equal spaces on the other as well. So let's go with the same process. Bring in my compass. There's my 5 equal spaces, and the final step, your sliding set squares, 5th space to the end of the line. So that's step 3 done. Divide up both sides. Step 4 is number away from the vertex again. So starting at the vertex, coming across and coming down to number 1, 2, 3, 4. Starting at the vertex, I'm coming across to point 1, 2, 3 and 4. And step 5 is to join the vertex to the point. So basically our construction starts now. The type of curve I want goes from the vertex. It doesn't go down towards this point 1. It goes across towards this point 1 and then down. So join and direct the curve with your first line. Direct the curve with the first line, and just like our rule, parallel to the axis from the other line, from the other point. So from point 1, parallel to the axis. Now in this case the axis is 60 degrees, so we're parallel to it, and that gives us a point in the curve. I'm going to just repeat that step then for all remaining points. And parallel to the axis from all remaining points here on this baseline. Finally, for this half, we freehand it in. Last job, we will mirror it across this time. So there's our path for one half. We want to mirror it across to the other half. Now, like my rule for every other one of these drawings, we want to mirror at 90 degrees to the axis through all of the points that we have just found. So at 90 degrees to this axis here. Now if this wasn't at a set angle of 60 degrees, we'd have to use sliding set squares or an adjustable set square. But because it is a 60 degree axis, well, a 30 degree projection will give us perpendicular. So using the same colour just for consistency here, through the axis at 90 degrees to the axis, just like every other time. Again, just like every other time, we'll bring in the compass. We'll lay the compass on the axis. We'll open it out to one side where we have a point, and then we'll find it on the second side. So there's all of our points on the second half. The final task is freehanding the curve. So there we have our third and fourth parabola. So starting off at the beginning, we had some very regular measurements to deal with our 120 and our 48, where 6 divides into both in a vertical orientation. We then had 5 dividing into both with a 100 and a 35. Then we had numbers that were given that just didn't happen to work out. The maths didn't work out for us, so we had to bring in our equal division of a line that we'd have learned back in first year. And finally, onto a parabola that's at a given angle. So this time it was 60 degrees, but regardless of what angle, even if it's set up on a page at a completely random angle, the only time that we'll have to really think about it is going parallel to the axis, where you could use sliding set squares, and going perpendicular to the axis again, sliding set squares. But this time again, with our random sizes, maths wasn't going to work out for us, so equal division of a line implied here, and once we've all of our points found and numbered, we'll just keep applying the same 5 steps for each of these. I hope these videos were useful. This should really help with getting onto some of the questions out of the book, or maybe even onto some previous exam questions. Thanks very much.